We're going to show that dy dx of this function equals y over 2y minus x. We're going to use implicit differentiation because of the way the x's and y's are all mixed together. And basically, every time we take the derivative of something with a y in it, we're going to follow our typical rules and then tack on a y prime. Well, in this case, I'm going to tack on dy dx. They do mean the same thing, but since this problem is written in terms of like dy dx, I'm going to use that notation, but it's the exact same concept, just a different way of saying it. So this guy's derivative is 2y times dy dx. I'm done with that portion. For this portion, I'll have to use a product rule, and I'll be very careful with that minus sign. So minus the whole quantity of this function times this guy's derivative, which is dy dx, plus this function y times that guy's derivative, which is just plain old 1. A little crazy like parenthesis there. So that's the product rule applied to this portion. And this is going to equal this guy's derivative, which of course is 0. And now this negative sign will get distributed. So I have 2y, y prime, minus x, y prime, minus y equals 0. If I look at this portion, this will stay on this side of the equation. This guy I'm going to move to the other side of the equation. So this side will just be y. When I factor out the dy dx, I'm left with a 2y minus a x. And of course, to get that dy by itself, that dy dx by itself, I'm going to divide both sides by 2y minus x, showing that, yes, it is true, dy dx does in fact equal y over 2y minus x. Now to find the second derivative, we're basically going to use the exact same type of rule. To take the second derivative, you just take the derivative of a derivative. In this case, it'll be a quotient rule. Give it a try yourself. I'll make a video showing how it's done. And